Hello! It's been a long time since we last met. I hope you guys are doing as well as ever. After a long summer, I'm continuing my work on the engine, and oh boy, I've done a lot of stuff this time around, cooking up some code, cooking up some plans, and finally, I'm ready to share something with you. Today's video will involve a lot of problem fixing, UI improvements, and me sharing my first plans on creating applications with the engine. Without further ado, let us begin. Today I'm starting by fixing the bug that has been in the engine from the very start. I cannot maximize the window. I can minimize it, but I cannot maximize it afterwards. And my computer starts making sounds like a combine harvester in a field. This was causing me a great amount of pain, so naturally, I avoided it. Until now. The issue was hidden deep in the application level code. I had to check for the window being iconified, and if it was iconified, the update and render loop would not execute. That in itself is not a huge deal, but my glfw poll events function was inside the update loop. You might be wondering what is this poll events function, and well, it checks for things like the window being maximized. Without the update loop, the application couldn't detect attempts to maximize the window. This also meant that the while loop was repeatedly checking if the window was iconified, consuming 100% CPU. I fixed this by always executing the poll events function, which processes events like keyboard input and Windows resizing, even if the window is minimized, so my prayers to Bill Gates to maximize it were finally answered. I also completely disabled rendering when the window was down, and set the update loop to happen at a maximum of 20 times per second, which would now allow our processor to live in peaceful temperatures. Great! After getting this huge weight off my shoulders, I started to think about the upcoming Vulkan support. Notice how I started thinking. I did some refactoring for the engine, such as separating DirectX loading, creating interfaces for graphics devices, and making several code improvements. I'm not sure if any of the interfaces I've created will fit Vulkan, but the code is now organized into logical blocks rather than being scattered throughout the project. I will in general take it slowly with Vulkan support to not drain the last 3 brain cells orbiting around nothing in my head. While refactoring, a lot of things stopped working. I was getting crashes, the engine would be rendering nothing, entities wouldn't render, and I realized that looking at an empty screen doesn't really help me debug the issues. It feels like a piece of my soul gets taken away with every time I had to add and delete C++ print statements in code. Basically, I have no tools for debugging engine systems. So I started working on some debugging tools. I implemented windows that can track all entities in the engine, including those in the engine backend. I added a way to see all existing components, which makes it very easy to visually verify if an entity is created, if it has components, if it is what I am expecting it to be. After I was finished, I realized, damn, there are so many windows already in the engine, like 5. And I thought about these handy menus at the top of the window where you can open and close windows, open engine settings, etc. I thought, I want that. So naturally, I started to barrage ChatGPT with questions about how the entire window actually works. If you look at the top of the window, you will see a very familiar design. Many applications on Windows have this title bar with the program's name and icon, along with the minimize, maximize, and close buttons. The first thing I wanted to do was get rid of it. It does not look modern, and I want my engine to have a sleek appearance. This will lead me down quite a rabbit hole, but I think the stuff I learned is very interesting. When you create a Windows window, by default, it actually has a lot of built-in functionality. Have you thought that you can resize the window, maximize it, move it around, minimize it, shut it down? These features come built in with the window and are called decorations. There are a few types of decorations in a typical window: a title bar and an icon, control buttons to minimize, maximize, restore and close the window, borders that can be used to resize the window, and there could actually be some other decorations. We can instruct glfw to remove them with a single line of code, which leaves us with just the rendering window. No window name, no buttons, no resize functionality. At this point, we cannot do anything with the window, not even shut down the application. So let's start adding new functionality and replace the window decorations within our own rendering context. With Imgui UI, I created an editor menu bar that will include several menus, such as File, View, Settings. For now, these are just templates and do nothing. At this point, I have already refactored all windows in the engine into ECS systems and created a small editor UI management system that will handle the new functionality. The first step is to just allow for a way to enable and disable all windows that are currently visible in the engine. By using a Boolean variable, I was able to individually disable rendering for each system locally and also added a way to control the systems from the editor UI management system. Next, I needed to replace window decoration functionality, starting with the minimize, maximize, and close buttons. This capability is handled by glfw, so with a tiny bit of code I was able to implement it. Unfortunately, this is where the simple part ended. Window movement and resizing requires detecting user input, which at the time I did not have any way to detect. This also means that I will have to interpret this input to correctly move the window. I fed glfw input documentation into ChatGPT and created quite a simple input system. This base framework for input isn't actually very complicated, as the entire input system just tracks the cursor position and button clicks and releases. This information is stored in unordered sets that contain all pressed, held, and released buttons, which are updated each frame. This way, the user can check the cursor position and specific key interactions in their own code each frame. For those of you thinking that I didn't really write an input system, since glfw is actually handling all the input, you are correct. Kind of. The truth is, input really isn't a thing you are solving at an application level. Physical input from your keyboard goes through a very complicated process. Since we're creating an application at the operating system window level, input is basically already handled. In essence, we're just observing input information that the operating system is already handling. We do this through glfw, which means that glfw isn't really handling input either. glfw is simply using the operating system's API, in our case, the Win32 API, to handle window messages like VM key down or VM mouse move. What glfw does, however, is that it detects which operating system the window is created in and automatically uses the correct API, so we do not have to create different input systems for Windows and Linux, for example. One thing to clarify here is that the input system we created is definitely needed. Not only is glfw API less comprehensible in a game development context, where input systems are common, but it also lacks features such as handling input buffering, debouncing, or custom key mappings, which we as engine developers are responsible for. While I was implementing the input system and meddling with IMGUI, I noticed an initialization function whose purpose I did not understand before. This function initializes IMGUI with a flag indicating whether to install callbacks, which essentially means that IMGUI handles its own input. For simple projects that do not detect input and just want to use the UI, this feature is very useful. But in our case, we already created an input system, and now both our input system and the IMGUI internally are polling input events. To improve this, we are going to disable IMGUI callback installation. This would usually make it impossible to interact with the UI. However, we can forward events from our input system to IMGUI. This way, our input system is the entire code in the entire application that actually checks the input at an application window level and forwards the information to every system that might need it. Later, for dragging the window, I created an invisible button using IMGUI and wrote some code to move the window around. I feel as if the window is not as snappy as before, but I'll iron these things out along the way. The most important thing now is to test the input system to ensure it works perfectly. Resizing proved to be much more difficult to implement, as I also wanted to implement docking for the window, correct mouse cursor icons and shapes. I spent quite some time on it, but couldn't get it right. For now, I settled with being able to move, maximize, minimize, and restore the window, as I want to get into more interesting stuff. What is this more interesting stuff, you might ask? I've been wanting to say these words for a long time. Now, after finally having a basic input system, I can say that I should be able to create games with the engine. This is probably not a simple task, but I will devise a step-by-step plan to achieve it. More about it in the next video, where I will be creating engine libraries, application packaging, explaining executable files, and maybe many more interesting topics. That's all I have for you today, you absolute beasts who stuck with me to the very end of the video. A huge thank you for watching, I hope you found this interesting, and maybe even learned something new. As always, likes, comments, and subscriptions are really appreciated. Until next time, bye!